Section 2.3 Linear Equations. So this time we will be dealing with linear equations of first order. If you recall from section 1.1, so this is the linear equation, the equation named number 1. And if you notice, why is it linear? First thing, why is it first order? It is first order because we see there is a first derivative of y being used in the equation. So that's why it is of order first. Why is it linear? It is linear because the power on this derivative is 1 and the power on the y is 1. So anytime a y or a derivative of y is used, the power should be 1, then it will be a linear equation. The order depends on what is the highest derivative being used. So this is a general linear equation in first order. So we have a function of x multiplied by the derivative dy by dx plus another function of x multiplied by y and equal to another third function of x, which you can call f of x, b of x, g of x. You can have many names. So this is what we say general equation, general form or general equation, first order linear equation. What is the standard form of the linear first order differential equation? Again, this is something we saw maybe before. So we divide by the function which is here. We divide the whole thing, so that cancels out and it comes a1x over here, and then it also comes a1x of x over here. Now these are new functions now, so we combine them and we call it p, and then we combine this and we call it q. So now the equation is looking like dy by dx plus p of x times y is equal to q of x. And why are we able to divide it by a1x? Because a1x is not equal to 0. Why not equal to 0? It is because if it is equal to 0, then you won't have this first term, then only you will have some function of x times y is equal to some function of x. Then it is not a differential equation. It is not a differential equation. It's not a first order differential equation. It's just simply an equation. So in order for it to be the first order linear differential equation, a1x must not be 0. That's why we can divide by it. So we look at two different cases. The first case is when a sub 0 of x is equal to 0. So we don't have this middle term. So our expression is only this much. So in this case it becomes much simpler because see, we have the y, we can see it only in this derivative or only in this differential up here. That's the only place we see the y. Everything else is in x. So we move everything else with x on the right side, and now we can integrate. So when we integrate at this stage here, the left hand side will give me just y, and on this side we will have a function of x. Let me now call this f of x dx. So whatever f of x is, this thing is, I'm calling it f of x. So now we can integrate by the rules and the methods that we have learned. Second case is when a sub 0 of x is not 0. So we have something. So then we start with this step that we first convert it into standard form. So we write our equation like this. We divide by whatever is in front here, whether it is a number or a function of x or whatever, but it should not be a 0. Okay. Then we find something we call integrating factor, and we denote it by this symbol. This symbol is mu, Greek letter mu, and so we are using it to name our function mu of x. Mu of x is the integrating factor. And what is the integrating factor? It is equal to e raised to the power integral of p of x dx. What is p of x? That is the quantity which we see here in the equation with as a coefficient of y. So we integrate p dx, and then we raise it to the power e, and then that is our mu of x. Once we find the mu of x and we actually do the integration and simplify things, once we get mu of x, then we multiply the whole equation by mu or mu of x. When we do this, we actually see that this is going to become much simpler. So the left hand side is actually going to look like dy dx of mu times y, and the right hand side will be mu times q. Now we integrate both sides, so integrate, actually we have to remove the dx over here and then integrate. So the left hand side just gives us mu y, because the d and the integral sign, they cancel out. So we end up getting mu y on the left hand side, and the right hand side we actually integrate whatever the function is. So it will be a function of x, so we integrate that. So let us look at one example here. It says find the differential equation, find the general solution of the differential equation given here. So I took a problem from the book actually. It says dy by dx is equal to x square e to the minus 4x minus 4y. So first thing we have to look at the equation and try to see if this is a separable equation. So you can see this is not a separable equation, because you can move the y terms on the left, keep the y terms on the left, and try to keep the x terms on the right. So you get dy by dx plus 4y is equal to x square e to the minus 4x. But now remember, we have to multiply by dx. So when we multiply by dx, this quantity gets multiplied by dx as well. So we get dy plus 4y dx is equal to x square e to the minus 4x dx. So you see we cannot separate the variables here. So this should not be done by separation of variables. So what method are we going to adopt? The method that I just explained, integrating factor. So the first thing is to put it in standard form. So standard form, so put in standard form. So putting it in standard form, it will be dy by dx plus 4 times y is equal to x square e to the minus 4x. So now you notice here that the p of x is, or just p, is 4, because it is the expression or the whatever is being multiplied by y, that is your p. And the q of x is the thing on the right hand side, so x square e to the minus 4x, that is your q of x. Okay, now we will find mu. In order to find mu, you have to integrate. So it's your choice if you want to separately integrate and then put it on the top of p, or you can do everything together. So if we do separately, so I take p and dx and integrate. So if you want, you can actually write it down. So it just gives me 4x. So what will be mu? Mu will be e to the, remember it's e to the integral of p dx. But we found that integral of p dx is 4x, so we get e to the 4x. That is your mu. Now the step is to multiply your equation by, so this equation in standard form, by mu. So I multiply that, so mu dy by dx plus 4 mu y, and then we actually have to replace mu by its expression, mu x square e to the negative 4x. which means e to the 4x dy by dx plus 4 e to the 4x y is equal to e to the 4x times x square times e to the negative 4x. Now look at this side here, actually this one. So what is this? If you note here, if you have a function e to the 4x times y and you want to differentiate that, what do you get? You will get e to the 4x multiplied by dy by dx. So we will use the product rule, plus now we will keep the y as it is and we will take the differential derivative of e to the 4x. The derivative of e to the 4x is 4 e to the 4x times y. So if you note, this whole thing is what we have over here. So now you don't have to write this step. You should always know that that is what is going to happen. Always this side, if you got the mu correct mu or the correct integrating factor, the left hand side is always going to convert into mu into y. What is y? Y is the dependent variable. So I'm going to erase this. And write the left hand side as d by dx of e to the 4x, which is mu, times y, and is equal to, now you can see on the right hand side, the e to the 4x and e to the minus 4x give us 1, and we are left with x square only. So the next step is to separate the differential. So it will be d of e to the 4x times y equals x square times dx. And now we integrate after this step. So now we integrate integral d of e to the 4x times y is equal to integral of x square dx. Now when we integrate, now we don't distribute this, we leave it as it is, because d and the integral, they cancel each other. So on the left hand side I am getting e to the 4x times y equals to, now on the right hand side I will integrate, so it will be x cube over 3 plus c. So next step is just get y by itself. Okay, so always remember, we should always try to get the y by itself. So it means I have to divide by e to the 4x. So this gives me y is equal to as we won't leave it like this. Actually dividing by e to the 4x means multiplying by e to the negative 4x. So this will be your solution. Okay, I'll stop here and we will do the next two examples in the next video.